Ben, I'm really excited to sit down and chat with you. We met, I think it was around 18, 24 months ago, really as this current AI wave was starting to explode and kick off. This was before your Series A. I think you were raising your Series A when we met, and you were like, we're about to close it. Don't tell anyone yet. But since then, Replicate's just become a very popular, almost household name within the developer community. And I'm really excited to sit down with you and just chat about what the last 18, 24 months has looked like from your point of view. You have a really unique perspective where a lot of products, AI products, are being built on with Replicate. And so I think your point of view and the insights that you've been able to gather over the last 2 years will be really interesting for people that are just starting to build with AI. I think to start, though, I would love to just hear about your founding story with Replicate. You started this company before this AI wave. So we'd love to learn about the founding story, what you saw, how you predicted that all this was coming. And it'd be great to start there.
Yeah, for sure. It's a very roundabout story because I quit my last job about 7 years ago. So it's been a long journey, but I'll give a kind of somewhat paraphrased version of the story. It came primarily from an old friend of mine, Andreas, who was a machine learning researcher and engineer at Spotify. And he spent a lot of his time, at the time, it was called machine learning for a start, rather than AI. And all of the advances were being published as papers, as academic papers. Like a lot of his job was taking some of these new advances that were happening in machine learning and applying them to real things inside Spotify. What he'd have to do is he'd have to take this academic paper, which described this machine learning model in kind of prose and math and try and turn it into like real production software. And it's just a nightmare because not all the details were in there. It was really hard to actually get it working efficiently and get it working in production. And the sort of tragedy of this is at some point that researcher actually produced a running piece of software at some point. They compressed it down to prose, and then Andreas had to uncompress it back into software again. I used to work at Docker, and I used to do products at Docker. I created Docker Compose, which is one of their core tools. And through conversations with Andreas, kind of connected back the problem he was seeing back to the things we were doing at Docker. Because at Docker, we kind of solved that problem for normal software by telling software engineers to just put their work inside this metaphorical box, inside this container. And then you would know that this piece of software would run on other people's machines, it would run in test environments, it'd run on all sorts of different clouds and all that kind of thing. So we took that sort of metaphorical container and literal container, it is powered by containers behind the scenes, to machine learning. And we thought, okay, what if we can get the machine learning researchers to put their work inside a box such that they could share it with other researchers and it could run in production on various clouds. And that's where the initial idea for Replicate came about. And we initially started with the research community. We created this place where where researchers could publish their work, but people could also use these models. It was packaged up in a way such that people could use these models for real world tasks as well, without having to kind of re-implement the paper. So we got started with the research community like that. And then while we were doing this, we noticed this really interesting community of people who were building models. What they were doing, I think they were trying to replicate, it's where the word comes from actually, we want to make research reproducible. They were trying to replicate DALL-E, and to do that, they were taking Clip, which was a model that's OpenAI open sourced, and they were smushing it together with a GAN to try and create images which looked like a piece of text. And what was really interesting about this community is they were doing it all in Colabs, which was very different to the research community. They were much more like open source hackers. So they were just tinkering around in Colabs, sharing them on Twitter, sharing them on Reddit, sharing them on Discord, and then riffing off each other ideas to like, oh, what if I swap out this GAN? What if I swap out big GAN with VQ-GAN? Or what if I tweak these parameters to see if we can get a better output? And people were just forking all these things like crazy. And that's where this really interesting initial text-to-image community came from. And we saw this and was like, this is really interesting. The time was really low quality. The images took like 15 minutes to generate. It was more like art than it was like a sort of crisp image of something. But that's almost like what made it interesting. And we built up with this community. We built tools for this community as well to help them share their, these collabs were very hard to use. They were unreliable. So we made a thing so we made a way such that they could make a really nice web form out of it. You could call it with an API, so you could integrate it into products. We sort of worked with this community and built a tool for this community, and then Stable Diffusion happened. And that's when these text-to-image models really reached the masses, and it's where we were positioned perfectly as the place where these models were. It's a place where people were publishing these models, and where people were tinkering on these models and making variations of them as well, which was really the interesting bit about the open source community. But right at that time, loads of people wanted to build products out of these models. People wanted to build image editors. They wanted to build AI avatar generators. They wanted to build generative games and all these kind of things. It was just around the time of ChatGPT where there was all this interest. And then it was just this sort of perfect storm of the supply and demand that just helped us grow.
So late 2022, early 2023, what did you see people trying to build right away with these Stable Diffusion models and with these image generators?
It was relatively simple stuff initially, as you can imagine. Partly it was just the core technology was really magical. For the first time ever, you could write a description of something you want and it just appeared instantly. So most of the initial traction and the initial products that were being built were just people plugging Stable Diffusion into an existing application or building a new application out of it. I remember the first app that went viral. We were seeing a huge increase of demand early on, and we were just sort of feeling the strain of it on our sort of on our kind of rickety sort of early infrastructure, and we were like, we have to completely rewrite our infrastructure. And then a few days later, this user from Japan emailed us being like, I'm going to be on Japanese TV next week. Is it all right if I send you this? I can't remember what it was, but hundreds of requests a second. And we're like, sure. So we had a deadline for rewriting the infrastructure. But what that app was, is it was just Stable Diffusion in an app with a bunch of like buttons to help you prompt. It was like, I would like this style, this style, this style, this style, and I would like this in the image. And it was incredibly compelling. It went viral in Japan. And just in those early days, this idea of generating an image was magical. The first thing where it got really interesting was when fine-tuning was possible. And the first system where it worked really well was a system called Dreambooth. And we built one of the first APIs for training these models where you can feed it 10 images of an object or a style. So it works really well with both. So you can feed it, one that's very common is feeding pictures of your face, and then you can generate pictures with you in it. And we saw lots of people build avatar apps. We saw people build things like generating things in the style of your game or your product or things like that. And that was the next thing that really took off. And the next thing was probably control nets. This was where you could control the output of the image or make it output things in a certain shape or things like that. And that also opened up a whole other sort of particularly good for image editing and things like that, where you need things to be constrained in a certain way. But they were the early things that were being built.
So image models are where you guys got your initial traction, where you started to see a lot of demand, and then open source language models started to happen.
Well, it was Llama 1 came out in April 2023, I think, or about that time, spring 2023. And what was really interesting about Llama is that it was the first really capable large language model, or within the same realm as the proprietary models like OpenAI's models. But it was tinkerable, and you could fine tune it, and you could mess with the code, and you could plug it into other models and this kind of thing, which really caught the imagination of the open source community. So there was this sort of community of hackers, a bit like that early Colab community with Stable Diffusion, who were tinkering on these models and making interesting variants of it. but it was encumbered by licenses, which meant you couldn't use it for commercial use. But that caught the imagination of the hacker community because it felt naughty. It felt like something you weren't allowed to do.
It was a leak.
Yeah, exactly, which made it really compelling to hack on. So that community sort of grew around there. But it was non-commercial. It wasn't really good enough. And it wasn't until Llama 2 where Meta kind of realized this was really interesting, and we should probably make a version here that's not encumbered by all this sort of research license. So that's when they made Llama 2, and that's when it really took off because Llama 2 was much better, and it was possible to use in products as well, and that's when it really took off.
So you guys have been at the forefront of the hacker community building with these text-to-image models, these diffusion models. And then you saw this happen with LLMs, because one of the things that's really cool with Replicate, and this didn't exist when we first met, was you can take a model and you can deploy it on Replicate, and then other people in the community can access that model. It really meets this ML in a box, the Replicate vision. I think what I'm curious about is how are you seeing people actually build products with these models, especially the ones that are finding traction, that are durable, that are creating a lot of end user value. And I think there's a lot of really cool demos on Twitter, and there's a lot of really cool prototypes, but there's a lack of those prototypes making it into production for various reasons. One of the stats I talk about a lot is that enterprise deployments of AI into production has actually gone down year over year, even though prototypes have gone up. When you splice the data across in production versus prototypes, these data citations are always like a bit fuzzy, but I do think that's probably directionally correct. You're in, again, a unique position. You're seeing so many products being built on Replicate. What are you seeing? Like, how are people actually building successful products on top of all of these 10,000 different models that are on Replicate?
One way to understand this is segmenting by different mediums. So, and different stages of the company as well. So I think language is quite different to image, audio, video, 3D, and other multimodal stuff. And things startups are doing is quite different from enterprises. And we're primarily building for startups. And when we say startups, it's both actual startups, but also small teams inside large companies that are kind of behaving like startups. These teams are having a lot of success building like either whole products that are native to AI or like particular point solutions to certain things inside their products. To give you a few examples of things that are really working with our customers, we have lots of people who are building consumer apps with generative AI. So people who are building these virtual photo shoot applications, which are enormously popular. Like some of our top customers are building these applications where you sort of create your own photo shoots. People are building image editing apps, which are either using generative AI as like a starting point for an image or as a way to edit images. So there are these whole startups that are built around these new mediums. We also see it being mixed into existing products in a really successful way. So I think generative, photo editing is a bit like that, but also generative game content where it's all of the sort of, we see people who are having conversations with their game characters using language models, where the content in the game is generated by image models or 3D models. Even audio and music is generated using AI as well. And that's just getting started, and that's sort of being weaved into existing products.
For all the developers and companies that are building these types of applications that you're seeing, how much stringing together of different models do they need to do? Are these models just working kind of off the shelf from Replicate? How much heuristics, duct tape is a word you've used. How much duct tape are they having to put around these things? I'd love to learn about what you're seeing there.
It depends a lot on the medium, I think. So language models, you can prompt them to do what you want to do quite effectively. And in fact, as prompts, as as context windows get larger, you can encode a lot of the behavior in the model in your prompts very effectively. So you don't necessarily need to customize the model. And from most users we talk to, most people aren't fine-tuning language models or customizing them to any extent, really. But we are seeing plenty of that for multi-image and multimodal use cases, which is really interesting. For people doing quite simple use cases, you can use these off-the-shelf models. But what we find is anybody doing anything sufficiently sophisticated, they need to customize the models, whether it's fine-tuning them, whether it's tinkering the code, whether it's plumbing multiple models together in some way. You need to be able to customize them somehow. So out of our top 10 customers by revenue, 8 are customizing the models to some extent. They're taking open source models and customizing them, whether it's fine-tuning, pipelining, or editing the code somehow.
But what you're seeing is that people were not interested in fine-tuning these LLMs. I'd love to just understand like that.
I think
that perspective.
something we're finding, I think it depends a lot on the medium. So again, image models and similar, non-language mediums are quite different from language.
Mm.
So what's quite interesting about image models is it's kind of, in some sense, unreasonably effective fine-tuning. Fine-tuning them is unreasonably effective. We can give it kind of 10 examples, and it can represent that object or that style extremely well. Whereas fine-tuning language models is much harder for whatever reason. And it might just be that we haven't got the right techniques yet, we haven't got the right tools, but you typically need to produce an awful lot more data. So it's on the order of thousands of examples instead of tens of examples. And it's much slower and more expensive to do. And it's much more finicky to get right for whatever reason. And it turns out that it's actually quite easy to prompt language models to get the result that you want. And my intuition for the reason that is that it's a few things. It's partly because it's the same medium in and out. So you're prompting text and text is coming out, but it's also a much sort of lower, has a much lower dimensionality, whereas things like image, audio, video, all these kind of things, it's very rich, information dense medium, whereas text obviously has a lot of information in it, but it's a lot less. So it's very hard, to be more specific about this, it's very hard to prompt an image model to get exactly the style you want. I couldn't prompt an image model to get Dylan into it. I mean, very difficult to get it to do that.
I hope so.
Yeah. But fine-tuning works so well for that. And I think another intuition here as well is when you're dealing with things that are not text, you need to work at a much lower level. It requires a lot more sort of duct tape and plumbing to get it to work right. You're like plumbing, it's almost like systems programming where you need to plumb these video models into audio models into text models at a very low level relatively in terms of programming these things to get them to be low latency and things like that.
So many follow-up questions to that. Because a year ago, even you might have been a proponent of, hey, fine-tune an open source LLM. It will be cheaper, it will be better, and that's the path you should go. Now it seems like you've switched camps. Or at least you're party neutral.
Yeah, it's a bit more nuanced than that. There are use cases of fine-tuned language models. And to be clear, we see customers fine-tune language models. And in fact, people are deploying fine-tuned language models on Replicates. It's just not a sort of first-class part of the product anymore.
What are those use cases where it does make sense?
Two things it works really well for is sort of similar to image models. Like if you want it to get to be in a very particular style, like if you have like a house style for how you write, or you want it to learn, a language or learn a programming language or something like that. A great example of where this works really well is if you wanted to get it really good at, so a customer that is deploying fine-tuned models and Replicates, their use case is they have a proprietary query language and they want to turn natural language into that query.
I see.
And for that, it's almost like teaching it a style. And that it works very well. It's possible to prompt it to do that, but fine-tuning actually works quite well for that. There's another use case where it works very well for is if you have a very specific thing you're trying to do, whereas it's like I'm trying to summarize legal text or something, and I want to do it as cheaply and fast as possible. And you can actually train a very small language model, like a 7B model, to perform as well as very large language model on just a very specific type, or just extract from this like freeform text, extract these text fields, but I want to do it incredibly cheaply. It's almost like when you want to really optimize the models, that's the point you do it. But what's interesting about this is that base models are getting better, base models are getting smaller, and proprietary models are also getting better and cheaper as well, better, cheaper, and faster as well. So for some of, it's just sort of a spectrum, and it's like a sort of equilibrium almost, where, maybe 6 months, a year ago, for some of those tasks, it would have made sense to fine-tune an open source language model. But today, it actually might make sense to build that on GPT-4o Mini. And in 6 months to a year, it might change again. It might shift around a little bit, or shift around in the same direction or another direction, or something like so. It's all kind of shifting around as the market changes, and just in a really interesting way.
And now, how are you seeing those dynamics play out differently in these other modalities? You talked about video, audio, image needing a lot more kind of in the weeds tuning and kind of peeling back the layers of these models and getting in there and getting your hands dirty. Why do you think that's the case? You spoke about the dimensionality. Do you think that those models are just weaker, underinvested?
To some extent, we just need to wait and see. I think there's some interesting developments with multimodal models that do like whole things end to end. And I think that's super interesting. In reality, for a lot of these kind of complex multimodal applications, there's almost always going to need to be some kind of duct tape involved. And I think what we find when these models hit the real world, you can't just ship a big model as the product. There's always going to be like some duct tape and some heuristics and some filters and some massaging of the output to make it behave how you want. So, however it pans out with how these models end up and how they behave, there's always going to be a lot of duct tape and heuristic involved in building products.
Are you seeing that as a pattern? Like
100%.
When it comes to building products, everyone's trying to I say fine tune, which is probably not the right word, but put that duct tape in place, get it to something that's like production quality.
Yeah, we see this both in our customers, but also a lot of the people in our team have built real products. And the sort of intuition for understanding this is it's very easy to make a really good prototype. And it's very easy to make something that looks really cool. But that is, to some extent, it's like most products, but to even more extreme extent, I think, that is 10% of the work. The remaining 90% is getting it actually working in production as a sort of reliable, robust product. And that is it's not a work on the model, but it's also just a lot of heuristics and duct tape surrounding it.
We see that too. Like a lot of that, I call it last mile work, is not even the fun, fancy, research problem. It's product development work. It's engineering work. It's putting those guardrails in. It's
testing with users.
Testing, exactly. Yeah.
I think something we're learning from the open source world as well is that we're building, so who we're building for primarily is the software engineer building products, but the sophisticated, ambitious software engineer who wants to use AI and learn about AI. So we're not building for like the machine learning researcher. We're building for somebody who's on the sort of a bit higher level, but digging down, if that makes sense.
I think I've heard you call them like the AI engineer.
Yeah, this was a term coined by somebody in the AI community called Swix. Yeah, it's effectively like an ambitious software engineer who can build AI systems at a high level, but they might not be kind of training models from scratch or anything like that.
They can get in there, they can tinker, they understand how it works, but they're not training models from scratch.
Exactly. Yeah. And we're building for that developer. And I think something we find from that developer, which is really interesting, and I think this is a software developer thing really, is that they don't want guardrails. They don't want to use things that feel like toys.
I'm curious, just because you've seen so many people build AI products on Replicate, that people start out with an idea of what they want to build, a product, a feature, or service. They then take it out to market. They put it in front of their users, their customers, and they completely change their plans, either because people interact with that thing differently or it didn't work as well as they thought it was going to. Are you seeing that as a pattern?
100%, yeah. And it's sort of a similar to building any kind of products, but I think it's just exacerbated by the fact that these systems are very complicated and people are not really sure what to do with them. Like with any product, it's coming from two sides. It can be either technology driven or it can be sort of pulled by the problem. So we see customers who are like, we have this problem with our product. Let me see if I can try and use AI to solve this problem. You sort of, try a bunch of things, try different models, see if it can solve the problem. Or, which is quite common, particularly for startups and particularly with a lot of kind of these new models that have come about in the past couple of years, there's this really cool piece of technology, and what new kind of products could we build with these,
Right.
or what new kind of features could we build in our application that could be done with these? And it's a mix of both, and both require iteration and experimentation, and it's a process.
So you guys have really like ridden the wave, I feel like, over the last 18, 24 months in a good way. I agree. I think there was this perfect storm of like Stable Diffusion and then Llama, and everyone was talking and thinking about AI, and Replicate was helping people to quickly experiment and prototype and customize AI for new products, for new prototypes. What's the biggest thing you've been surprised by over the last 2 years with all the AI craziness that's just kind of taken over?
I think one thing that's been really, as you've experienced as well, just the extraordinary, the rate of innovation has been incredible, just been utterly extraordinary, particularly in the sort of midst of some of the developments last year. Just a new thing was coming out each week that was not possible before.
Yeah, I think coming into January 2023, compared to now, like the perspective of most people on just what the market would look like is and the tooling layer would look like is so different. It's been crazy. Well, cool. Thank you so much for sitting down with me. It's been awesome to chat with you today, and really appreciate you doing this.
Yeah, it's been great fun. Thanks for inviting me.
Thanks.